Section 2.6 talks about radical equations in one variable. Section 2.5 talked about what kind of equation? Say what? Rational equations in one variable. Good. So this time we're going to talk about radical equations in one variable. What do you expect to see in these types of equations? X? That's the variable, yeah. What else do you expect to see? A square root, because it says what? Radical. Does it only have to be square root?
It could be cube.
It can be cube root as well, right? Because it's a radical. Yes? Okay, so that's what this section is about, equations that have those things appearing in them. A radical, square root, cube root, and variables. Okay? So what we want to learn here is we want to learn how to solve radical equations. So we want to learn how to solve equations with positive rational exponents and solve equations for one variable. So let's start out with the definition. A radical equation is an equation that has at least one radical expression containing a variable, while any non-radical expressions are polynomial terms. Okay? A radical equation is an equation that has at least one radical expression containing a variable, while any non-radical expressions are polynomial terms. Okay? So let's talk about how to solve radical equations. So this is the process. First, you want to isolate the radical expression on one side of the equation, if it's possible. If there's more than one radical expression, choose one to isolate on one side. This just says we want to get the radical expression on one side by itself if it's possible. So I just rephrased one. One says we want to get the radical expression on one side by itself if possible. If there are two expressions that have radical expressions, we want to get one by itself. Okay? Second thing we want to do is we want to raise both sides of the equation by the power necessary to undo the radical that we got by itself. And then the third step is if there are any other radical expressions left, then we have to repeat steps 1 and 2. And then you always, whenever you're solving radical equations in one variable, you have to check your solutions in your original equation because you may have to reject some of the solutions. You get extraneous solutions. Okay? So we're going to look at an example. Okay? We really don't need to do the example from page 3, but I do want to get through parts A and B. Okay? So we want to solve the radical equation. We have the square root of 50 plus 7x, that quantity minus x equals 8. First step says we want to get what by itself? The radical expression by itself. So what do we need to do? Add x to both sides. Good. So we want to add x to both sides because we want to get the radical expression on a side by itself. That's what it means to isolate it. So that leaves us with the square root of the quantity 50 plus 7x equals 8 plus x. And then the next step said, go ahead. You gotta say what? Is the square root gonna undo the square root? The square, right? If you square both sides, that's gonna undo the square root, right? So that's what we want to do. The idea is to undo whatever radical we have. So we're going to raise both sides to the, is that right to say 3?
I thought it was 2.
Yeah, it's 2, right? That doesn't make sense. Right? So this is the square root of 50 plus 7x quantity squared equals the quantity 8 plus x squared. So then on the left side, that square root and the square cancel, leaving us with what? Leaving us with what?
50 plus 7x equals 8.
What do we have to do on the right-hand side? You have to do what? Use the FOIL method to expand it, yes? Good. right? So now we still have to bring the left side down. Using the FOIL method, first, when you multiply, you get what? For the first, you get 64. For the outside, you get what? Oh, plus 8x, yeah. And then for the inside, you get plus 8x. And then what? Plus what? Yes. So that gives us 50 plus 7x equals 64 plus 16x plus x squared. We want to combine like terms. So I'm going to move everything from the left to the right to keep x squared positive. So I'm going to subtract 50 and subtract 7x from both sides. You with me? Okay, so that gives us 0 equals what?
14.
Continue.
Plus 9.
Plus what? 9x?
Plus x squared.
Plus x squared. And because I want to arrange the right side in descending order, I'm going to write 0 equals what? Talk loud. Yes. And so now you can factor as what? 0 equals?
X times 7.
You said x times 7?
X plus 7.
X plus 7 times
Plus times
x plus 2. Good. So then that gives us x plus 7 equals 0, or x plus 2 equals 0, which means x equals what? And then x equals negative 2. And the last step says we have to do what? Last step of the process, we got to check, right? We got to check to see if we got any solutions we have to throw away. Where do we check? Yeah, that's the location, but what do we check these numbers in?
Oh, in the equation.
In your original equation, let's highlight it. We check our solutions in the highlighted blue. So let's check. So if we substitute in negative 7, that gives us 50 plus 7 times the negative 7 minus a negative 7. We hope that's going to be 8 when we simplify it. So it's the square root of 50 minus 14 plus 7. 50 minus 14 is 36. Square root of 36 plus 7. Oh, is that plus 7? Are we right? What's 7 times negative 7? Oh, yeah. So what's wrong? We need to go back and correct that, right? Yeah. Add it instead of multiplying. Let's be right. So this should be minus 49. So this is the square root of 1. Square root of 1 is 1, right? So you get 1 plus 7, which is 8. Does it check? Yes, we got 8. Good. So we know negative 7 works. Then the question is, does negative 2 work? So you have the square root of 50 plus 7 times negative 2 minus negative 2. We hope it's 8. You get the square root of 50 plus or minus what? So minus 14. What's the rest? Plus 2. This gives us what? Square root of what? What's 50 minus 14? 50 minus 14 is? 36. You get the square root of 36 plus 2. The square root of 36 is? 6 plus 2 is? Does it check? So your solution set is negative 7, negative 2. So both work. And so then, in part B, what you're going to do Do you want to just go through part B? Might as well. Curb your enthusiasm just a little bit. Okay, so part B. We have the cube root of 3 minus 2x minus the cube root of x plus 1. Yes?
I got a question. How do you go from 2x plus 9, how do you go from 2x squared to plus 1?
Excuse me?
How do you go from 2x squared plus 9x plus 14 to the parentheses?
We didn't have 2x. We have x squared.
Yeah, that's what I mean. How do you go from
We factored it. So you want two numbers that multiply to give you 14. That's 7 and 2. And you want them to add up to be 9. So 7 plus 2 is 9. 7 times 2 is 14. Okay. So here you have the cube root of 3 minus 2x minus the cube root of x plus 1 equals 0. We isolate. So that's the cube root of 3 minus 2x equals the cube root of x plus 1. What do we do to both sides now? You got it. Raise it to the third power. That cancels out the cube root. So something that looked really challenging becomes very simple here. So you got 3 minus 2x equals what? X plus 1. What do you want to do? Put everything on one side, the left or the right? Okay, so I'm going to move everything to the right so the variable can be positive. So we're going to subtract 3 and add 2x. We're going to subtract 3, add 2x. So that's going to give us 0 equals x plus 2x is 3x. And then 1 minus 3 is negative 2. Yeah? And so then we get 3x equals, or 2 equals 3x. Divide both sides by 3. And you get x equals 2 over 3. And then you go through and check. Remember to check it. It does work. So check it. You'll get your solution set is 2/3. And that's this section. That's it. Okay? Have a good one. We'll move on to section 3.1 and 3.2 on Thursday. You'll have a group activity on Thursday too. Have a good one.